Hi friends, welcome back to another session of engineering mechanics. Currently we are dealing plane trusses. So in this session we are going to learn method of joints, method of sections, and we try to do a few numericals on both method of joints and method of sections. So let us start with method of joints. Method of joints. Method of joints. Write 2-3 points about this method of joints. First point, in this method, equilibrium of successive joints are taken. Equilibrium of successive joints are taken. Successive joints are taken. If total truss is in equilibrium, every element also will be in equilibrium. Every joint also will be in equilibrium. In method of joints, first we take equilibrium of a joint, then we find some unknowns, then we shift to next joint. Again at that joint, we try to find unknowns. Like that man, after joint after joint, joint after joint, joint after joint, until the intended unknown is found, we move on like that. So here the principle is, if total truss is in equilibrium, every joint of truss also will be in equilibrium. So you take one joint and you draw a vector diagram of the joint. So what forces are acting on that joint? You present all those forces in the form of a vector diagram, then deal that vector diagram. So we all know, by using vector diagram, only two unknowns you can deal. Sum of all forces along x equal to 0, sum of all forces along y is equal to 0. Only two equations I can write by using a vector diagram. Two equations means two unknowns I can deal. So you can select any joint, man, but number of unknowns about the joint should not be more than 2. Like that you have to select joint. You take any joint, but number of unknown forces about the joint should not exceed 2. So second point, number of unknowns about chosen joint, about selected joint or chosen joint, about chosen joint should not be more than 2. Should not be more than 2. Should not be more than 2. Like that you have to select a joint, right? For example, about a joint, number of unknowns is 3. So by taking that joint, you cannot find anything, because by taking equilibrium of a joint, you cannot find 3 unknowns. Maximum you can find 2 unknowns. Okay. Usually, third point, at the beginning, find support reactions. At the beginning, find support reactions. Find support. In most of the problems with method of joints, we find support reactions, then we proceed. Always it is not necessary, but majority of the times we need support reactions. Okay. So this is regarding method of joints. Without wasting any further time, we try to do some numericals by using method of joints. While doing problems, you will understand everything, right? So you may refer numerical number 33. Numerical number 33. Numerical number 33. So in this numerical, a truss is given. A plane truss is given. Left support is hinged support. Right support is roller support. Right support is roller support. It is placed on rollers. And these two are joined. And this is A, This is B, this is C, D, E and F. At C, a downward load of 1 kilonewton is acting. At E also another 1 kilonewton is acting. Another 1 kilonewton is acting. Here link lengths are also given. So this is L, this is also L, this is also L, this is also L, this is also L. This is L, this is L. So definitely this angle should be 45 degrees. This angle also 45, right? This is also 45. Similarly, this is 45. Why 45? Tan of angle means opposite side by adjacent side. Opposite side is L. Adjacent side is also L. L by L is 1. At what angle tan is 1? It's 45, right? This is 45. This is also 45. And even this is 45, right? So please copy. This question came in GATE exam, GATE 2001. So this numerical came in GATE 2001 question. So what to find here? First you copy this diagram, then I dictate what to find. So in this problem we have to find what is force carried by member CD. What is force carried by member CD? First look at the problem and try to use some shortcuts, man. If no shortcut works out, you have to follow either method of joints or method of sections. Here you cannot use any shortcuts. So definitely you have to use either method of joints or method of sections. Here I am going to use method of joints. So first I try to find reactions. Here loading is symmetric. 1 kilonewton, 1 kilonewton. This is L, this is also L. So obviously reaction about A is RA. This is 1 kilonewton. Reaction about F is RF. This is also 1 kilonewton, because total load is 2 kilonewtons and it is applied at symmetric points. So RA will be 1, RF is 1. Here both the loads are vertically downward, actions are vertically downward, reactions will be vertically upward. So about hinged support there shall be 2 reactions, but here 2 actions are only downward, so only upward reaction will induce. If the stress carries any horizontal load, definitely there shall be a reaction about A in horizontal direction. Since both the loads are vertically downward, reactions will be like this, man, right? So about roller support, always reaction acts perpendicular to supporting plane. This is supporting plane, so definitely reaction will act perpendicular to this. This is the phenomenon, right? Now we have to start with a joint. We have to take equilibrium of a joint. Which joint we can take? Okay. So first I may proceed. If I take this joint, how many unknowns will come? I don't know force carried by this, I don't know force carried by this, I don't know force carried by this, I don't know force carried by this. If I take joint D, 4 unknowns are coming. 4 unknowns you cannot find by taking a joint. Similarly, if you take this joint, 3 unknowns are coming. I don't know force carried by AB, force carried by BC, force carried by BD. I don't know these. So I cannot take joint B. If I take here again 1, 2, 3, 4, 4 unknowns are coming. If I take here 3 unknowns are coming. So here only 2 unknowns are there. Here only 2 unknowns are there. So you can take joint A or joint F. If number of unknowns about a joint is more than 2, you should not take that joint. You cannot find 3 unknowns by using equilibrium of a joint. So number of unknowns should not exceed 2. So I am taking joint 2 here, joint A here, right? So joint A, about joint A, RA is acting in upward direction. So this is 1. And I assume member AC carries tensile force. Member AC carries tensile force. And member AB also carries tensile force. I don't know whether they carry tensile force or compressive force, but I am assuming both are carrying tensile force. This is TAB, this is TAC. When 2 arrows are approaching each other, it indicates tension. So I assume member AB carries tension, member AC also carries tension. Now, with respect to A, what is direction of TAB? Here there are 2 arrows. This arrow is nearest to A, this arrow is upward. So definitely TAB is upward. So this is TAB. Now, with respect to A, what is direction of TAC? This is TAC, man. There are 2 arrows. This arrow is near to A. This arrow is pointing towards right. So I can draw like this. This is TAC. This is TAC. So this angle is 45 degrees and this is joint A. How many unknowns are there about joint A? Only 2 unknowns, TAB and TAC. TAB and TAC. Okay. So since this joint A is in static equilibrium, sum of rightward forces equal to sum of leftward forces. Sum of upward forces equal to sum of downward forces. What are sum of rightward forces? Sum of rightward forces means TAC plus TAB cos 45. The horizontal component of TAB is TAB cos 45. Then what is sum of leftward components? Towards left, no force is acting. Just I am putting this as 0. This is my equation number 1. Then sum of upward components equal to sum of downward components. Sum of upward components means 1 plus TAB sin 45 equal to, so vertical component of TAB is TAB sin 45, right? Then there is no downward component here. I am putting 0. So here there are 2 equations, 2 unknowns. You can easily find what is TAB and what is TAC. So here TAB sin 45 equal to -1 and TAB is equal to minus root 2. So sin 45 means 1 by root 2 and bringing 1 by root 2 other side, it becomes root 2. Minus root 2. TAB is minus root 2. Now on putting this TAB in above expression, TAC plus TAB cos 45. So TAB is minus root 2, cos 45 is 1 by root 2 equal to 0. Root 2 will be cancelled. On bringing minus 1 to other side, plus 1 will come. So TAC is equal to 1 kilonewton and TAB is equal to minus root 2 kilonewton. So since you are getting positive value here, your assumption is correct. You assume TAC is positive. You are assuming TAC carries tension. Since you got positive value here, really it is carrying tension only. But TAB, I assume TAB has tension. Since I got negative value here, TAB is not tension. TAB is compressive force. Okay, so either you can change direction of these arrows or still you keep this TAB as it is and assume TAB is equal to minus root 2. Either you change direction of those arrows of TAB and treat TAB is equal to root 2, or you can keep same arrows and you treat TAB is equal to minus root 2. As it is, you may follow, right? So TAB is minus root 2 and TAC is 1 kilonewtons. Okay. Next, what joint I have to take? If I take the joint C, what is the next joint of A? Already we taken joint A. The neighboring joints of A is either B or C. If I take joint C, how many unknowns will come? I know TAC, but I don't know this, I don't know this, I don't know this. So, three unknowns are present about joint C. I cannot take joint C. What is the alternative? Joint B. About joint B, three unknowns will be there. Load carried by this member, load carried by this member, load carried by this member. Out of these three, already I know TAB. Already I know TAB. Only number of unknowns about joint B is only 2. So, please copy this, then we take another joint, that is joint B. So, here I am writing, right of this TAB is equal to minus root 2 and TAC is equal to 1 kilo Newton. I don't take directions, I don't change this, as it is I take. So I think you copied. Now let us take joint B. On taking joint B, what happens? So here I am taking joint B. This is B. And I assume member BC carries tensile force. I may call this as TBD. Member BD is carrying tension. That is my assumption, man. I don't know whether it is carrying tension or compression. And I assume this member also carries tensile force. And I call this force as TBC. Now, with respect to B, what is direction of TAB? This is joint B. I am talking about TAB. What is nearest arrow to B? This is B. There are two arrows here. This arrow is near to B. This arrow is directed towards, directed downwards or directed upwards? Directed downwards. So you draw this vector. This is TAB. So this angle will be 45 degrees, man, right? Now, with respect to B, what is TBD? Here there are two arrows. Which arrow is near to B? This arrow is near to B. What is direction of this arrow? Rightward or leftward? Rightward. So TBD is rightward like this. This is TBD. And with respect to B, what is direction of TBC? There are two arrows here. This arrow is near to B and this arrow is directed below. So that is way downward. So this is TBC. So here I am assuming every force is tensile force, man, right? Assume every member carries tensile force and do the problem. If you get positive value, indeed it carries tension. If you get negative value, that is not carrying tension, it is carrying compression. So assume every member carries tension. Do the problem. If you get positive value, it is tension. If you get negative value, it carries compression. Like that you can understand. So this is joint B. Joint B is in static equilibrium. Since joint B is in static equilibrium, sum of rightward forces equal to sum of leftward forces, sum of downward forces equal to sum of upward forces. What is sum of rightward forces? There is only one rightward force, that is TBD. And what is horizontal component of TAB? TAB cos 45. TAB cos 45. Now, TBD is equal to TAB, already I know, TAB is minus root 2. So, minus root 2 into 1 by root 2. Root 2 will cancel. Then obviously I am getting minus 1 kilonewton. TBD is minus 1 kilonewtons. That means BD also carries compression. BD also carries compression. Okay. Now, sum of downward forces is equal to sum of upward forces. Sum of downward forces means TBC plus TAB sine 45 equal to 0. What is TBC? I don't know. TBC plus what is TAB? TAB I know, minus root 2. So minus root 2 into 1 by root 2 equal to 0. Minus root 2 into minus root 2 by minus root 2 minus 1. I'm bringing minus 1 to other side. So it becomes 1. So TBC is 1. So here we found another 2. TBD I found. TBD is minus 1 kilonewton and TBC is equal to 1 kilonewton. You have to understand, since TBD is negative, member BD carries compressive force, not tensile force. And TBC is equal to 1 kilonewton. That means it is carrying tension. Now, which joint I have to take? What is neighboring joint of B? Either D or C. If I take D, how many unknowns I have to deal? Of course, I know what is force carried by TBD, but I don't know force carried by this, force carried by this, force carried by this. So, about a joint, I cannot deal 3 unknowns. I can deal only 2 unknowns. What is the other option? This option. If I take joint C, how many unknowns are there? Already I know what is TAC. Already I know what is TBC. I don't know what is load here, what is load here. Understand? So, I take joint C. So, please copy, then I take joint C. If total truss is in equilibrium, every point of the truss, every joint of the truss also will be in equilibrium. If any point is in equilibrium, sum of rightward forces equal to sum of left, sum of downward forces equal to sum of upward forces. This concept we are using. These are nothing but principles of static equilibrium. Alright, I hope you copied. Now, I take another joint. What joint? Joint C. About joint C, what forces are acting? About joint C, a downward force of 1 kilonewton is acting. And with respect to joint C, what is direction of TAC? This is TAC. This is TAC. With respect to C, what is direction of TAC? What is nearest arrow? This is the nearest arrow. This arrow is directed towards left. So TAC will be like this. And what is TAC? 1. This is 1. With respect to C, what is direction of TBC? This is TBC. There are 2 arrows. Which arrow is near to C? This arrow is near to C. Is it directed upward or downward? Upward. So TBC is upward. And what is TBC? TBC is also 1. And what is TCE? I assume TCE also tension. So in method of joints, I am assuming every force is tension, man. I am doing my problem. If I get positive value, indeed it is tension, otherwise it is compression, right? With respect to this C, what is TCE? TCE is rightward. This is TCE. Then I assume even TCD also tensile force. So this is TCD. With respect to C, it is also upward, right? This is TCD and this is 45 degrees. We have to find what is TCD, man. We have to find what is TCD by using method of rectangular components, or directly also you can say upward force is 1, downward force is 1. These two forces will balance each other. If you remove these two forces, only 3 forces are there. Out of these 3, these 2 are collinear. What is force carried by third member? 0. Like that also you can understand, or you can write like this: sum of rightward components equal to sum of leftward components. Sum of upward components is equal to sum of downward components. From that also you can say TCD is 0. The answer is 0. Member CD carries 0 force. That's what I am saying, man. In most of the gate problems, the answer could be 0 in trusses. Please copy. So the answer is 0. TCD is 0. Let us move to next numerical, that is 34th numerical. 34th numerical. This is again a previous gate question. This question came in gate 2003. So gate 2003. So here a truss is given, just like previous truss. Here a truss is given like this. So left support is hinged support and the right support is placed on rollers. This is A, this is B, this is E, this is F, this is C, and this is D. Of course I have to join like this. This is L, this is also L, this is L, this is also L, this is also L, and an UDL is acting on member EF like this. So this is P Newton per meter, right? P Newton per meter. This UDL is P Newton per meter. So what is force in member CD? The question is, what is TCD? What is TCD? You have to find. So just copy it. This is a previous gate question. Right. First, let us try to find equivalent point load of that UDL. Equivalent point load is equal to UDL into distance P into L, and that equivalent point load could be assumed as acting through centroid, of the loading. So a point load is acting at center of the truss. So half of this load will be acting on this support, remaining half will be here because load is exactly acting at center. So definitely I can say RA is PL by 2 and RB also PL by 2. Alright, so first from what joint I have to start my solution? Obviously here we have to find load carried by the CD, and of course directly I can say this member carries 0 load because here 3 members are joined at C. Out of these 3 members, 2 members are collinear. The third non-collinear member carries 0. So let us take joint A first. By taking joint A, I can find TAC and TAE. Immediately I will get TCD, right? So let us take joint A. So about joint A, RA is acting in upward direction. It is PL by 2. And I am assuming AC carries tensile force. So I may refer this as TAC. And I assume even TAE also tension. With respect to joint A, TAC is rightward, this is TAC, and with respect to A, TAE is upward, this is TAE, and obviously this is 45 degrees and this is joint A. Since joint A is in equilibrium, sum of rightward components is equal to sum of leftward components, sum of upward components is equal to sum of downward components. Sum of upward components PL by 2 plus TAE sin 45 equal to what is sum of downward components? There is no downward component, 0. So TAE sin 45 is equal to minus PL by 2. And what is TAE? TAE is equal to minus PL by 2 into root 2. Sin 45 means 1 by root 2, on bringing 1 by root 2 to other side, root 2. So this is TAE. Then sum of rightward components is equal to sum of leftward components. Rightward components TAC plus TAE cos 45 equal to 0. There is no leftward component here. We know what is TAE, right? TAC, what is TAE? Minus PL by 2 into root 2 into cos 45 means 1 by root 2 equal to 0. Root 2 is cancelled. On bringing this minus PL by 2 other side, it becomes plus PL by 2. So TAC is equal to PL by 2. So TAE is this much. Of course, it is minus PL by root 2. Here PL by 2. Now let us take joint C. Immediately I can take joint C. About joint C, how many unknowns are there, man? I know force carried by this member is 0. I know force carried by this member. So only one unknown is there. So I assume it is also tension. TCD also tension. Then by taking joint C, this is the phenomenon. With respect to joint C, TCD acts towards right and TAC acts towards left. TAC already I know this is PL by 2. So here no forces are acting. So this is joint C. What is TCD, man? You know, joint C is in static equilibrium. So sum of rightward forces equal to sum of leftward forces. So directly I can write TCD is equal to PL by 2. This is answer, man. So member CD definitely carries tensile force as I imagined, and it is equal to PL by 2. The answer is PL by 2. Please copy. In method of joints, I am assuming every member carries tension. Then I am doing my job. If I get positive value, tension. If I get negative value, compression. For example, here, I assumed member AE carries tension, but I got negative value here. That means member AE carries definitely compression. That is the thing. So this problem has been done by taking only 2 joints, okay? Sometimes 2 joints, sometimes 3 joints, sometimes even 1 joint. Right. Look at problem number 35. Problem number 35. So this is very much similar to previous problem, except so this is pin jointed support. This support is roller support. So here a force of 1 kilonewton. Here a force of 1 kilonewton is acting. This is B. This is C. This is D. This is E. And this is F. Refer problem number 35. Refer problem number 35. Let us try to deal this problem, right? So since loading is symmetric, of course this is L again, this is L, this is L, everything is L, this is also L, this is also L. Since loading is symmetric, definitely I can say RA is 1 kilonewton, right? So RA is equal to 1 kilonewton and RE also equal to 1 kilonewton, okay? Now take joint C, man, take joint C. Of course, this problem is given and you have to find what is load carried by member BC. What is load carried by member BC? So directly you can do this problem. Take directly joint C. About joint C, a downward load of 1 kilonewton is acting. In upward direction, TBC will be there because I am assuming this member carries tensile force. This is TBC. Right of this, TCF will come. Left of this, TAC will come. TAC will come. I am assuming every member carries tension. Every member carries tension. What is TBC, man? So direct. Sum of downward forces is equal to sum of upward forces. So TBC is equal to 1 kilonewton and I can say TAC is equal to TCF. Currently I don't know what is TAC and what is TCF. By taking this joint you can easily find it. Okay. The answer is 1 kilonewton. Please copy. If you want to find either TAC or TAB, take equilibrium of this joint, directly will get it. So similarly, even if they can ask what is TDF, TDF also equal to 1 kilonewton. So these two are collinear, these two are collinear, these two forces are perpendicular to these two forces. So in this scenario, directly we can write, okay? The answer is 1 kilonewton. Let's move to another numerical. The next numerical will be numerical number 36. Numerical number 36. Right. Numerical number 36. So here a roller support is provided. Here a hinged support is provided. This is 1 meter and this is 45 degrees. This is also 45 degrees. This is also 1 meter. Since it is 45, it is 1 meter. This will be also 1 meter, right? So this is A. This joint is B. This joint is C and this joint is D. This joint is D. And this is E. So here we have to find what is load carried by member BC. We have to find what is load carried by member BC. Member BC is vertical, man, right? Like that you have to draw. Vertical line, horizontal line. These three are forming a right angle triangle. Okay. So we have to find what is load carried by member BC in this problem. So first you copy, then we do it. So don't think these are laborious problems. As you practice more and more problems, within seconds you can do all these things. So nothing is difficult if you practice well. First observe joint A. About joint A, two non-collinear members are joined without carrying any external load. That means those two members will carry zero load. Zero load, zero load. If two members are collinear, they need not carry zero man. When two non-collinear members joined by a pin joint without external load, those two members will carry definitely zero force. So member C and member D will carry zero force. So since they carry zero force, I need not worry about these two members. Man, simply I remove this. I remove this. Okay. So now what joint I have to take? So member BC, you have to find what is load carried by member BC. First think about B or C. Can I take B? If I take B, how many unknowns will come? I don't know. Force carried by this, force carried by this, force carried by this, three unknowns. I cannot deal. The B you cannot take. Can you take C? Again about C, three members are joined, so three unknowns will come. I cannot deal even joint C. So B and C you cannot deal, man. Then what is neighboring joints of this B and C? Either this or this. Can I take this? If I take this joint D, I can find these two. Once I know, I can take joint C. Okay. So let us take joint D, and I assume this member carries tensile force. I call this as TCD. I assume this member also carries tensile force. I don't know, man, whether they carry tension or compression. This is my assumption. About joint D, a downward load of 1 kilonewton is acting. With respect to D, what is TCD? TCD is leftward. With respect to D, what is TBD? TBD is downward. This is TBD. If this angle is 45, this angle also 45. And this is joint D. Okay. This joint D is in static equilibrium. Now I can easily write sum of rightward components equal to sum of leftward components. Sum of downward components equal to sum of upward components. What is sum of downward components? 1 plus TBD sine 45. TBD sine 45 is equal to 0. So there is no upward component here. So from this, I can write TBD is equal to minus root 2. You bring 1 to other side, it becomes minus 1. Sine 45 means 1 by root 2. And bringing 1 by root 2 other side, root 2, minus into 1. Minus 1 into root 2, minus root 2 kilonewtons. TBD is minus root 2 kilonewtons. Now, I want to find TCD. Sum of leftward components equal to sum of rightward components. In leftward direction, TCD is acting, and this force may carry leftward component. Leftward component is TBD cos 45. There is no rightward component. Now, TCD plus what is TBD? TBD is minus root 2. Minus root 2 into 1 by root 2 is equal to 0. Cos 45 means 1 by root 2. So root 2 will be cancelled. Here you will get minus 1. On bringing minus 1 to other side, the TCD will be 1 kilonewton. So since it is positive, member CD carries tension only, man. And since it is negative, BD carries compressive force, not tensile force. BD carries a compressive force of root 2 kilonewton. Here negative sign indicates compression, positive sign indicates tension. Okay, this is about joint D. Now, what joint I have to take? I can take either this joint or this joint. Which joint is better? If I take this joint, I need not worry about reactions. If I take this joint, I have to find reaction about B, man. So, it is better to take joint C. If I take joint C, things will be like this. I assume this is also tensile force. I call this as TBC. I assume this is also tensile force TAC. Now with respect to C, what is direction of TCD? Rightward. What is TCD? 1. So this is 1. With respect to C, what is direction of TBC? Downward. This is TBC. With respect to C, what is direction of TAC? Again downward. This is TAC. What is this angle? Definitely this angle also. If this angle is 45, this angle also 45. So this is 45 degrees. Right? Now in this problem, I want to find TBC, man. So first, okay, this is joint C. Since joint C is in equilibrium, sum of leftward components equal to sum of rightward components. What is leftward component? TAC cos 45 is equal to 1. I don't know what is TAC. So TAC into 1 by root 2 is equal to 1, and the TAC is equal to root 2. TAC is equal to root 2. So TAC is root 2, man. So it is positive, that means it is carrying tension. Now let us think about downward components and vertical components. Sum of downward components. TBC plus TAC sine 45, and there is no upward component. So here in upward direction no component is there. Now TBC plus what is TAC? Root 2. Root 2 into sine 45 means 1 by root 2 equal to 1, equal to 0 man. Sorry, it is 0. It is also 0. Root 2 will be cancelled, and bringing 1 to other side, minus 1. TBC is equal to minus 1 kilonewtons. Okay. So force carried by member BC is a compressive force of 1 kilonewton. A compressive force of 1 kilo, minus indicates compression, man, right? A compressive force of 1 kilonewton. So in GATE exam they give answers TBC is equal to 1 kilonewton compression or minus 1, both are same. So please copy. So in this problem, without finding support reactions, we found TBC. So always we need not find support reactions. Sometimes without finding support reactions, we can find the force carried by a particular member. Right. So always in method of joints, we need not start from supports. What we do is, for example, in a truss, I want to find maybe TBC, right? Or here TBC you confuse, TCD, right? What is TCD? What is force carried by member CD? First you think about joint C or joint D. If number of unknowns about joint C is more than 2, you cannot take it. Then think about D. If number of unknowns about joint D is again more than 2, you cannot take D. Sometimes, number of unknowns about C could be 2 or less than 2. Sometimes number of unknowns about D, 2 or less than 2. So first think about these two joints. If it is not possible to take these two joints, think about neighboring joints of these two, which may carry only 2 unknowns or less than 2 unknowns. First you have to think about these two joints. If it is not possible to take these two joints, you have to think about neighboring joints of these two joints. Right? The number of unknowns about a joint should not exceed 2. That is the problem. Take neighboring joints, find unknowns, then come to this joint C or joint D. Okay? So, if a problem is given, first look at shortcuts. Can you apply any shortcut? If you are unable to apply any shortcut, then look at the problem again. Sometimes without finding support reactions, you can find unknown force. Sometimes you have to find support reactions. But always, if they ask you what is TCD, think about C and D. Try to take joint C or joint D. If it is not possible, go for neighboring joints of this C and D. Okay? So this is the end of the session. In coming session, we are going to do few more numericals on method of joints, and we are also going to learn method of sections, how to use method of sections to find an unknown force. Okay? So until next session, have a great day. Thank you.